Hello everyone. Again we meet here to solve more problems. Perhaps this could be my last session for problem solving. My first illustration is a straight line passes through 8, 2 and cuts the positive coordinate axis at points P and Q respectively. The minimum value of OP plus OQ, where O is the origin, is, and now four options are there. We have to pick up the right option. Now, when I say a straight line passes through 8, 2 and no other information is given to me, so I can actually draw infinitely many lines through 8, 2. So I draw the figure, some one line I am showing through 8, 2 and that point 8, 2 I have named as A. It meets the coordinate axis, that line passing through 8, 2 meets the coordinate axis at P and Q as given in the problem. Now P and Q are variable positions. As I said that infinitely many lines could have been drawn through 8, 2. This is just one of the positions. So basically position P and position Q, they are varying positions. And hence what happens, length OP and length OQ also vary and hence the sum also varies. Now you must understand one thing, question is regarding minimum value of OP plus OQ. So when do we ask or when do we talk about minimum or maximum? The quantity has to be a variable quantity. Unless it is a variable quantity, we cannot answer minimum or maximum. If quantity is fixed, will it have any meaning? I mean, if I ask you what is the minimum and quantity is fixed, that doesn't happen. So, minimum is asked means first of all, we will have to check whether it is a varying quantity or not. And as I said, since OP and OQ are varying quantities, hence OP plus OQ is also varying quantity and I am in a position to find minimum. Fine. Now, from here, what I do is, I try to write length OP. I have shown in the picture theta. Mind you, please, this theta is not the inclination. I am showing only the angle as theta. And length OP turns out to be 8 plus 2 cot theta, which is very much understandable from the figure. And I also write OQ, which is 2 plus 8 tan theta. So basically, tan theta and cot theta, those are variable quantities. And OP plus OQ is 10 plus 2 cot theta plus 8 tan theta. So basically 2 cot theta plus 8 tan theta, this is a variable quantity for which we have to find minimum. 10 remains constant, which can be added only at the end. Okay. So how do we find 2 cot theta plus 8 tan theta's minimum value? Now since you have not done perhaps some other chapters, so I try to take one particular result. A minus B whole square is a non-negative quantity that everybody knows. And that would be equivalent to saying A square plus B square minus 2AB greater or equal to 0. I add on both sides 4AB and I get A square plus B square plus 2AB is greater or equal to 4AB and A plus B whole square greater or equal to 2 under root AB whole square, which leads to finally A plus B greater or equal to 2 root AB, which is equivalent to A plus B upon 2 greater or equal to root AB. Actually, A plus B upon 2, that is called arithmetic mean, and under root AB is geometric mean. So what I have written here is arithmetic mean is greater or equal to geometric mean, which is a standard result. And when does that equality occur? Equality occurs when you take those quantities of which you are taking arithmetic mean and geometric mean. Those two quantities are equal. Then only equality would occur. Otherwise, only strict inequality would occur. I hope you understood what I am saying. If A and B are equal, then A plus B by 2 and under root AB, they would be equal. If A and B are not equal, then A plus B by 2 would always be strictly greater than under root AB. Using this, can I write 2 cot theta plus 8 tan theta upon 2? That would be greater or equal to, yes, it would be under root 2 cot theta into 8 tan theta, which is simply under root 16. And under root 16 would be 4. And from there I get 2 cot theta plus 8 tan theta greater or equal to 8. Now, out of curiosity, you must ask, does equality occur? Because unless equality occurs, we are not in position to say so and so value is minimum. Can I say 2 cot theta plus 8 tan theta's minimum value is 8? If equality does not occur, then how would we say that 8 is minimum? For that, I check and I just write there for my own conscience that equality occurs only when 2 cot theta and 8 tan theta, these two quantities are equal. And that would lead to tan square theta equal to 1 by 4. Tan square theta equal to 1 by 4 is some equation which is solvable. So I can surely get some value of theta for which tan square theta is 1 by 4. And hence I can say 2 cot theta plus 8 tan theta would be 8 for some value of theta, and hence minimum would be nothing but 8, and still 10 is to be added. So minimum required value would be 10 plus 8, so 18. So the correct answer should be A. Now there is still some remark which is regarding AM and GM, means arithmetic mean and geometric mean, which you can keep in your record. That is why I have written here separately. And using that also, you could have straight away found the answer. So correct option is A. And from here, then I move to the next one. And next illustration is that one side of a rectangle lies along 4x plus 7y plus 5 equal to 0. Two vertices of the rectangle are minus 3, 1 and 1, 1. Then the equations of other sides are, and we are given some 4 options from where we have to pick up the correct one. Now, which two vertices are minus 3, 1 and 1, 1? No information is given to us. It's only that one side is given by 4x plus 7y plus 5 equal to 0. Okay. So I draw the figure. Some rough sketch only I have drawn, that I have shown one side as 4x plus 7y plus 5 equal to 0. And frankly, at this moment, I do not know what are the positions A, B, C, D, etc. Now, if I write point A as minus 3, 1 as shown in the figure, why I must have done that? Because that satisfies. I realize that point A satisfies 4x plus 7y plus 5 equal to 0. So point A or point D, anyone I could have named as minus 3, 1. But point C does not satisfy. Okay. Now it could be position B also. And for that I have found slope of AD, that is 4 by 7, and slope of line joining 1, 1 and position A, which is minus 3, 1. And that turns out to be 0. So I understand that surely point C cannot be at position B, right? And hence I have written the opposite vertex as C. Okay, so basically what I have found is minus 3, 1 and 1, 1 are opposite vertices. Now what about slope of AB? Slope of AB is 7 by 4. Why do I say so? Because it is AB is perpendicular to AD and slope of AD is minus 4 by 7. So it's negative reciprocal. So slope of AB is 7 by 4. From there I will be able to write equation of AB, and that by using point and slope form, I am writing that as y minus 1 equal to 7 by 4 times x plus 3, which can be simplified further, and I get one equation for AB. Now what about slope of DC? Now DC is parallel to AB. If slope of AB was 7 by 4, so is slope of CD also. And hence from there I can write equation of CD, and that is y minus 1 equal to 7 by 4 times x minus 1, which can be simplified to 7x minus 4y minus 3 equal to 0. So I have found equations of AB and DC by now. And what is now left one? Left out is equation of BC, what I have to find. So what about slope of BC? Slope of BC I can find same as slope of AD, because AD and BC are parallel. So minus 4 by 7 is the slope. From there I can write equation of BC also, because one point is known to me. I use slope point formula and I further simplify that equation to 4x plus 7y minus 11 equal to 0. So I have found remaining 3 sides equations, and the correct option from there I find that as A. Now this was quite simple question, except the fact that position of C we had to fix first before attempting the equations of the sides. I think this is good enough for this session, and here I end my topic straight lines. Hope you enjoyed this session. If you have liked the video, please click on this side to subscribe, and if you want to place an order for the book, please click on this side. Thank you.